Hello everyone, welcome in the class of geography. So, as you know, we already discussed about one of the major topic of the section of oceanography, and that is the reliefs of ocean basin. In the two previous classes, I discussed with you the two major sections, the two major parts of the reliefs of ocean basin topic, that is the major relief basin and major reliefs of ocean basin and minor reliefs of ocean basin. Right? Now, in this section, I would like to introduce the new topic of oceanography, that is the physical properties of ocean water. When we discuss about the physical properties of ocean water, two physical properties must be considered here according to our syllabus. The first physical property is the temperature of the ocean water. The second physical property is the salinity of the ocean water. If we go through the previous year questions which have been asked regarding these topics, particularly in the preliminary examination, these topics are important there. So, according to our previous year papers and previous year questions, we come to a point that we have to see here the major factors which are affecting and controlling the temperature and salinity of the ocean water. Here we have to discuss the sources of the temperature and salinity of the ocean water. What are the sources for these two physical properties? And the third and the major thing which we'll discuss here is the distribution of temperature and distribution of salinity in the whole ocean water. So obviously, when you think about these two physical properties, obviously consider these things in your mind and then start studying and reading about these two physical properties of ocean water. For example, if I take take one of the oceans, say it is Atlantic Ocean. So in the Atlantic Ocean, if I take the first physical property as it is temperature, so here we have to think that from where the Atlantic Ocean gets, the water of Atlantic Ocean gets temperature. How we'll discuss the degree of hotness and coldness of this Atlantic Ocean. Second thing, what are the factors? And if you see, not before the factors, here we will see that if we see the water of Atlantic Ocean, so in the whole water of Atlantic Ocean, you can see that the mode of temperature of or the hotness or coldness of the water of Atlantic Ocean is not similar, is not uniform, is not equal everywhere. And when I say that everywhere, that means here we have to consider the whole of the ocean water in two modes. In two different views, we will see the ocean water. What are those two views? One of the views is we have to see the temperature of Atlantic Ocean from equator towards the poles. From the equator towards the poles. And the another view is that we have to see the distribution of temperature from the sea surface up to the bottom of the ocean water. On the whole, you can say that when we discuss about the distribution of temperature from the equator towards the poles, it may be seen as the horizontal distribution of ocean water, horizontal distribution of temperature in the ocean water. And when we discuss about the distribution of temperature from the sea surface up to its bottom, it can be seen as the vertical distribution of temperature in the ocean water. The two things, in two ways we will discuss the distribution of temperature. So distribution of temperature suggests us that the degree of temperature or the value of temperature in the Atlantic Ocean is not uniform when we go from the equator towards the poles or when we go from the sea surface up to the bottom. Got it? So in that way you can say that obviously there will be so many of factors which basically control such kind of distribution. So we have to start with the sources for the temperature of the ocean water, from where the ocean water gets heat, and according to the amount of heat it absorbs, we'll talk about the temperature, the degree of hotness or coldness of the ocean water. That is called temperature, right? The degree of hotness and coldness of anything is called as, or it is described as, the temperature of that thing. So in that way we'll discuss the sources first of all, and then we'll discuss how this temperature get controlled by different factors so that the distribution of temperature is seen not uniform. It is not seen uniform in any modes, in the horizontal mode or in the vertical mode. And when we'll come to know about those factors, obviously further we will be able to discuss about the modes of or trends of the horizontal distribution as well as the vertical distribution of temperature in the ocean water. So in all the oceans, particularly when we discuss about the properties of ocean water, particularly we will discuss these properties in three different oceans, like the Atlantic Ocean, the Pacific Ocean and the Indian Ocean. Because these are the oceans which basically tell us their distribution from the equator towards the poles, their latitudinal expansion or their latitudinal you can say distribution is very in a very large area, in a very vast area. And so that these oceans tell us about the various modes, these oceans tell us about the various properties which we want to discuss here, right? So let us start with the chapter. Here, as I told you that we have to discuss, according to our syllabus, we have to discuss the two of the properties. One of the properties is the temperature of the ocean water. Second is the salinity of ocean water. So in this session, I'll discuss with you the temperature of the ocean water first, and then we'll discuss the salinity of the ocean water in the next session, right? So let us start with the temperature of the ocean water. Okay. Here, the first line I have written, that is, this section deals with the spatial and vertical variations of temperature in various oceans. So many of oceans are there on the Earth's surface. Particularly, as I told you, in three of the oceans we will discuss all these things: Atlantic, Pacific and Indian Ocean. But what are these? Here we have to discuss these temperature of the ocean water in a spatial manner, that means pertaining to the space, and also vertical variation. Vertical variation, that means spatial, when we talk about spatial variation, that means the horizontal distribution or the horizontal variation, and the vertical variation from the sea surface up to the bottom of the ocean water, right? Then as I told you that we have to discuss about the sources of temperature of ocean water. So two of the sources are very important, right? Here I would like to tell you the sources, right? So when we'll discuss about the sources of the ocean water, sources of heat for the ocean water. So the major and the prime source, as we all know, and if I ask you, I hope that you all know that the major source for the heating of ocean water is the sun, right? The sun is the major source of heating of the ocean water, and this heat, when the amount of heat in the ocean water which is stored there, when we talk about the degree of hotness and coldness of the ocean water on the basis of the amount of heat that is stored in the ocean water, we can say it tells us about the temperature of the ocean water. So the major source is always the sun. And here we have to know that ocean water, unlike the land surface, you can say, unlike the land surface, the ocean water gets its heat in two ways. In two ways, the temperature of the ocean water and its distribution, the variation in the temperature can be assessed in two ways. What are those two ways? So one can say that if it is the sun, say if it is the sun, so primarily we all know that the solar radiation which are coming from the photosphere of the sun, it is received on the surface. The solar radiations are received on the surface, right? These surface may be the land surface or the water surface. So since we are talking about the ocean water, we can say that the radiations are received on the surface of the ocean water. And so that the water at the surface of the ocean water absorbs these radiation and get heated up. Got it? But unlike the land, the ocean water has a typical property. And that typical property is, since it is water, it is transparent. Land is not transparent. But ocean water is transparent. So when we say ocean water is transparent, these radiations are able to penetrate the water through its surface, and it also the radiations reach inside the ocean water. They also reach inside the ocean water. And that is how these radiations also directly heats up the ocean water below the surface. Okay, so in two ways. It is the first way where the radiations are directly heating up the ocean water on the surface as well as below the sea surface. Below the sea surface, the radiations are penetrating, and since the ocean water is transparent, the radiations also reach inside the ocean water, and then the water molecules get heated up directly by the radiation. One thing you must consider here, that these radiations are not able to reach the bottom of the ocean water. No. They are not able to reach the bottom of the ocean water. They are able to cover only a limited depth in the ocean water. And so that the zone in the ocean water which get heated up by the penetration of these radiations, that zone in the ocean water is called as the photic zone. It is called the photic zone. Photic zone means the illuminated zone. And why it becomes illuminated? Because the radiations are able to penetrate in that zone. radiations are able to penetrate in that zone. That is why it is called the photic zone. And then after, when radiations are not able to cross that limit of photic zone, the remaining zone is darker, the remaining zone is not illuminated, and that is why that zone has been called as the aphotic zone. That zone is called as aphotic zone. So normally it is observed by the geographers, it is observed by the oceanographers that in the ocean water, from the surface of the ocean, the radiations are able to penetrate up to a limitation of 200 meters. And that is why from the ocean surface or from the sea surface up to 200 meters, you can consider that zone as photic zone. Then after 200 meters depth, we have aphotic zone up to the bottom of the ocean water. Okay, this first thing you must consider here, that the ocean water is getting heat for it directly from the solar radiation, and these solar radiations are not only received on the ocean surface, but also they are able to penetrate the ocean water, because ocean water is transparent, and so that these radiations can reach up to a certain limitation, up to a certain depth, which depth got illuminated due to the penetration of the solar radiation, and that is why that zone has been called as photic zone. And in the photic zone, we will see the heating of ocean water directly from the absorption of radiation, absorption of solar radiation. This is one of the way of heating of ocean water. What could be the second way? So the second way could be that when this solar radiation is received on the surface of the ocean water, the surface gets heated up, and after its heating, you can see that now that amount of heat is further distributed below the surface, in the region below the surface, by which process that this heat is distributed further. So as I told you in the earlier classes or in the earlier sections, that the distribution of temperature, the transmission of heat particularly, the transmission of heat takes place in several ways. Transmission of heat takes place with the process of conduction, with the process of convection, with the process of radiation, and with the process of advection. I told you all these processes in the earlier classes. If you are not able to recall those, obviously go and see your notes in the chapter of heat budget we did there in the portion of climatology. There we have already discussed about the process of transmission of heat in the modes of conduction, convection, advection, and radiation. I told you all these things there. So now consider here and recall that the transmission of heat in the water and in the gases takes place through the process of convection. Convection is the process which basically defines us that the transmission of heat takes place through it in the gaseous medium as well as in the liquid medium. In the liquid medium, particularly on the earth surface, we have to discuss about the water. Got it? So by the convection, you can say the heat which is absorbed here at the surface through these radiation, right? Now this heat is distributed further below the surface in the region below the surface, and so that this region gets heated up, so in two ways I told you about the heating of the ocean water. The first way is the radiation that is received not only on the surface of the ocean water, but it is also able to penetrate the ocean water inside, and so that below the surface of the ocean water, it is able to heat up the ocean water up to a certain depth, and that depth is covered under the photic zone. And the second thing I told you, the second process I told you about, that is the process of convection. By the process of convection, the ocean water gets heated up. So the major mode of heating of ocean water is, it is the radiation. By the radiation of the sun, the ocean water gets heated up, and that is why the solar radiation is the major factor. The solar radiation is the major factor, not factor, it is the source, the major source for the heating of the ocean water. But apart from this major source, if you have been giving some other sources, obviously you have to think about those. One of the sources I would like to introduce here is, apart from the sun, it is the volcanic eruptions. The volcanic eruptions. See, in the chapter of reliefs of ocean basin, we have discussed about the formation of seamounts, the formation of guyot, the formation of mid-oceanic ridges. If you remember that, we have discussed that all these relief features have been formed there due to the eruption or upwelling of the hot magmatic material on the abyssal plane or on the deep sea plane of the ocean. On the deep sea plane, when you say explosive eruption takes place at a time, so huge amount of very hot magmatic material comes out. That magmatic material is not particularly called as magma there, it is called as lava. So due to the explosive eruption of lava, the material of lava inside the ocean water, you can say so much heat is provided to the ocean water. Much amount of heat is provided to the ocean water. And that amount of heat to the ocean water also changes the degree of hotness or coldness of ocean water. You can say it is able to change the temperature of the ocean water. So in that way, you can consider that volcanic eruptions are also one of the sources. But since volcanic eruptions are not so frequent, so that the changes that is brought by these volcanic eruption is not, those changes are not so significant. Only during the time of eruption and after some time of the eruption, the change in the temperature of the ocean water can be observed. Then after, with the passage of time, again the temperature of the ocean water becomes normal. It will become normal. Got it? So this is again one of the sources, but you can consider it one of the source. Here I would like to tell you that when we'll discuss about different factors and other things regarding the temperature of the ocean water, there we will consider only that the temperature which is found in the ocean water is only received from the solar radiation. We will deliberately neglect the other sources because these sources are not so significant for the particular time period or for the particular point of time. These sources are able to affect the temperature of the ocean water, but these sources are not actually such sources which are able to continuously providing the temperature to the ocean water. Got it? The heat to the ocean water. That is why we'll talk about and we'll consider only the sun or the solar radiation as the major source. Got it? Okay. Now, one more source you can see here. It is not actually source, but it is a kind of process which basically affect the temperature of the ocean water. And by this process, you can say the ocean water get heated up in a particular region, and that is called as compression of ocean water, or sea water in the zone of high pressure or high air pressure, you can say. See, when we talk about different pressure zones, different regions of pressure in the ocean water, there we will discuss the different pressure zones like the equatorial low pressure zone, then subtropical high pressure zone, then subpolar low pressure zone, and then polar high pressure zone. We have different pressure belts, we have different pressure zones, but particularly where we'll discuss about the high pressure zone. A high pressure zone region is either the subtropical high pressure zone or the polar high pressure zone. When we say that a region is having high pressure conditions, that means air is subsiding at the surface. Air is subsiding on the surface, and so that a kind of compressive force is applied on the surface. This compression causes the increase in the density of the substance. It is very obvious now. It is very obvious that if something is putting pressure on the surface, so it actually is squeezing that particular material. And so that with the help of pressure, you can say the increase in the density of the material can be observed. If it is so, this thing is also applied in the zone of subtropical high pressure belt and the polar high pressure belt. In both these regions, air is particularly subsiding, and so that it put a compressive force. The air puts a compressive force on the surface of the ocean water. Due to such compression, the amount of heat or the degree of hotness or coldness, or you can say the temperature of the ocean water, it is brought to a certain limitation. Due to its compression, you can say now the amount of heat becomes more in a particular volume of the water. and so that it also affects the temperature of the ocean water. By this process, you can say temperature also get affected. But here again you can say it is not particularly the source. It is a kind of process by which the temperature is getting changed in certain regions of the ocean water. Got it? So here I told you about the sources. For the sources, you have to consider always that the sun is the major source, the solar radiation is the major source, volcanic eruption is a minor source. It provides some amount of heat energy or in a particular time, not or, in a particular time period and in a particular region of the ocean water, because when volcanic eruption takes place, it takes place only in a certain region, in a certain part of the ocean water, not everywhere. So that in that way, the amount of heat which is provided to the ocean water, it also changes the temperature of the ocean water. Got it? So in that way, we have discussed about the sources. Okay, now come to this section. As I told you that ocean water gets heated up by the solar energy just as land. I told you about the land, but I told you that there is a kind of difference here. Land is not transparent, land is opaque, ocean water is transparent, and so that the amount of radiation which is received by the sun, received from the sun, it is received on the surface of the earth or a little deeper below the sea surface or below the ocean surface in the water, right? So in that way you can say one thing, we make it clear. We made it clear. Okay. Now come here. The process of heating and cooling of the ocean water is slower than land. We all know and we came across this phenomenon so many of time. So many of time we have discussed that the land is getting heated up and cools down very rapidly. Water is getting heated up and cools down slowly. And different reasons I told you about that. The main and the particular thing is the specific heat of the water and the land surface. We have also the opaqueness and transparency of the land surface and ocean water respectively. These are also the factors. Got it? So obviously it is also one of the things which we have to consider here, that the process of heating and cooling of the ocean water is slower than land. Got it? Okay. Now come to the factors which affect the temperature distribution. What are those factors on the basis of which we can see the temperature in the ocean water which is not seen uniform everywhere? So why this temperature is not found uniform everywhere? It is changing in the horizontal manner as well as in the vertical manner. What are those factors which basically affect this? So particularly the things which and the factors which I have discussed here and which I have written here, these factors are actually telling us the changes in the horizontal distribution, right? Changes in the horizontal distribution. The first factor you can consider here is the latitude. And whenever we will discuss about latitude, we always discuss that from the equator towards the poles, what would be the trend of distribution of temperature? How the temperature is getting changed from the equator towards the poles. Got it? So here, when we talk about latitude, it is very obvious that as on the land, we have seen that on an average, temperature is getting decreased from the equator towards the poles. It also happens on the ocean water. Ocean water is not exception in that manner. Likewise, the land on the ocean water, you can also find that from the equator towards the poles, the temperature is getting decreased, right? So what is written here, that the temperature of the surface water decreases from the equator towards the poles because the amount of insolation decreases poleward. It is the major thing. And all we know that obviously the amount of temperature, the amount of you can say radiation, right, or amount the insolation, incoming solar radiation, decreases from the equator towards the poles. It decreases from the equator towards the poles. So obviously the value of temperature also decreases, right? So in that way, latitudes are affecting that. Okay, it is one of the factors. Second factor is unequal distribution of land and water. So how unequal distribution? Here, when we talk about unequal distribution of land and water, we have to consider here the two hemispheres of the earth, the northern hemisphere as well as the southern hemisphere. When we talk about the southern hemisphere, it can be called as oceanic hemisphere because here larger proportion of the surface is covered by the oceans. Only some patches of lands are found there as the part of South America, as the part of African continent, and as the part of oceanic continent, Oceania continent, that covers a part of Australia and also some of the island countries of the Oceania continent. But the major part is covered by the ocean water. Unlike the southern hemisphere, the northern hemisphere is called as the land hemisphere or terrestrial hemisphere because here maximum proportion of the surface is covered by the land surface. There you can find the larger land area of Asia and Europe and a larger land area of North American continent. And only some part of ocean are found there, particularly Indian Ocean is not there in the northern hemisphere. Only a little part of Indian Ocean can be found in the northern hemisphere. In the form of Bay of Bengal and Arabian Sea, you can find the part of Indian Ocean. And some part there in the Atlantic Ocean, if you see, and in the Pacific Ocean, you can see. These parts are also surrounded by major land parts or major land area. So maximum coverage by the land surface is seen in the northern hemisphere and maximum coverage by the oceans is seen in the southern hemisphere. Okay. So what is written here? The oceans in the northern hemisphere receive more heat due to their contact with larger extent of land and the oceans in the southern hemisphere. Now what is important here to discuss, that if the northern hemisphere is considered as the terrestrial hemisphere, it is considered as a land hemisphere, and as we all know that the land surface gets heated up and cools down very rapidly. So particularly when it is time for the heating of the land surface in the northern hemisphere, the distribution of temperature is seen. The distribution of temperature is seen more to the ocean water. Got it? And in that way, you can say that the distribution of temperature in the ocean water increases the value of temperature in the ocean water. While if we see the oceanic water in the southern hemisphere, it is not in much contact of the land part. in the southern hemisphere, the ocean water is not in much contact of the land part. And that is why the distribution of temperature is not taking much there. So if we compare the temperature of the ocean water in the northern hemisphere as well as in the southern hemisphere, we can see that due to the transfer of some more amount of heat from the land surface in the northern hemisphere, the temperature of the ocean water, the average temperature of the ocean water, not only temperature, you can use the term average temperature. The average temperature of the ocean water in the northern hemisphere is a little more than the average temperature of the ocean water in the southern hemisphere. It is the particular thing, and this is caused due to the unequal distribution of land and water. In that way, you can discuss these things. Got it? In that way, you can discuss these things. Okay. So this is the second point. Now come to the third point, and it is very interesting, that is prevailing wind. Now, if I ask you about the prevailing wind, the major thing that comes in your mind is the trade winds, the westerlies, and the polar winds. These three kinds of winds are considered as the prevailing wind. And if I ask you about the definition of the prevailing winds, you can say that the winds which are blowing in a particular zone between the two pressure belts, two particular pressure belts, in a definite direction throughout the year, such winds are called as prevailing winds. This is the common definition for the prevailing winds. And in that way, we came to know that the trade winds, the westerlies, and the polar winds, all these three are covered under the prevailing winds. In the northern hemisphere as well as in the southern hemisphere, they are attaining a particular direction. All we know. Now here, since we are discussing about these prevailing winds as the factor, one of the factors controlling the temperature of the ocean water, the prevailing winds controlling the temperature of the ocean water only on the surface. Because winds are considered as the horizontal movement of air, and if it is affecting the temperature of the ocean water, so it basically creates a kind of friction at the surface of the ocean water, and so that it causes the change in temperature only on the surface water of the ocean, not in the deeper zone. And in the two previous factors, we have also seen that the changes in temperature is observed only on the surface. So likewise, those two factors, the prevailing winds, are also affecting the temperature condition on the surface of the ocean water. Now consider the things. Here I would like to tell you about that how prevailing winds govern the changes in temperature. So for this, you have to consider this diagram here. Say it is our globe, and on this globe we all know about the formation of different pressure belts. So with these lines, I am showing you the different pressure belts. With these lines, I am showing you the different pressure belts. In the middle, we have equatorial low pressure belt. Just above it and below it, we have subtropical high pressure belt. Above the subtropical high pressure belt and below the subtropical high pressure belt in northern hemisphere and southern hemisphere particularly, we have the subpolar low pressure belt. And then nearby the polar region in both the hemispheres, we have the polar high pressure belt. Okay. Now all we know that between the subtropical high pressure belt and equatorial low pressure belt, the winds which are considered as the prevailing wind, these are the trade winds. Not only in the northern hemisphere, these trade winds are also blowing in the southern hemisphere, but their directions are different. In the northern hemisphere, they are blowing from northeast to southwest. In the southern hemisphere, they are blowing from southeast to northwest direction. But since this direction, in this direction, the winds are blowing throughout the year in these regions between these two pressure belts, so they are considered as the prevailing winds, all we know, right? On the whole, one can say, if we are not taking these directions as northeast and southwest and southeast and northwest, on the whole, we want to say, one can say that these winds are coming from east to west. On the whole, in the both hemispheres, the winds are coming from east to west in these ways, from the eastern side up to the western side. Now consider here that if I make a piece of land here, if I make a piece of land here, it is the piece of land here. If I show a piece of land here between these winds, what you can observe, and not only in the northern hemisphere, you can observe it in the southern hemisphere too. So see here, what we can see here, we can see that the winds are coming from east and they are going to the west. Now, if you consider this piece of land here, in between these winds, so one can observe that the winds are, the trade winds are onshore on the eastern margin of the land, on the eastern coast of the land, and these winds are offshore on the offshore for the western coast of the land. Isn't it? It is, right? So whether it is northern hemisphere or the southern hemisphere, the winds, the trade winds are onshore for the eastern coast and offshore for the western coast. So when the winds are blowing, and say they are blowing on the ocean surface, they are blowing on the sea surface. So wherever the winds are blowing on the ocean surface, they cause a kind of friction over the sea surface, on the water of the sea surface. And so that they are able to drag the water of the sea surface, the water of the ocean surface, in the direction they are moving. If they are moving from east to west, they are able to drag the sea surface water or the ocean surface water from east to west. Isn't it? Okay, now if they are dragging up the ocean surface water from east to west, obviously they are able to, since they are onshore along the east coast of the continent, they are able to pile up the ocean surface water or the sea surface water here along the east coast. They pile up so much of sea water, sea surface water here along the east coast. Why it is so? Because they are onshore wind. They are a kind of onshore wind for the eastern coast. They are coming towards the eastern side, eastern coast of the continent. And as I told you, they are not doing this only in the northern hemisphere, also in the southern hemisphere. You can see the same thing. Got it? So piling up of warm surface water, because the surface water of the sea, the surface water of the ocean is always warmer. It is always warm, because it is the region which directly receives the solar radiation, which directly receives the insolation. So if the ocean water is receiving, the solar radiation here, it gets heated up, and the surface water of the ocean, the surface water of the sea is piled up here along the east coast of the continent. Why? Because of the impact of these onshore trade winds. For the eastern coast, these trade winds are onshore. And that is why, due to this process, you can say nearby the eastern coast of the continent, nearby the east coast of the continent, the temperature of the water is found more than the remaining part of the ocean. Why it is so? Piling up of warm water due to onshore trade winds or onshore prevailing winds. Now, one thing which is common for the coastal region, that wherever the prevailing winds are onshore for the coastal region, there is piling up of warm surface water, and so that the temperature would be a little more than the remaining part or the rest part of the ocean water. Got it? Got it? Okay. Now see the second thing. If I was talking about the onshore winds, let us talk about the offshore winds. See, the nature of wind is similar, whether it is onshore or offshore. It is causing a kind of frictional force on the surface water. So wherever these winds are moving, they are able to drag the surface water in that direction. Now see, for the western coast of the continent, the same trade winds are becoming offshore. The same trade winds are becoming offshore. And if they are offshore, they obviously drag up the sea surface water or the ocean surface water with them. Where? Away from the coast. Along the eastern coast, these trade winds are coming towards the coast. Along the west coast, they are moving away from the coast. So if the winds are moving away from the coast, they are called as offshore winds, and so that they are able to drag up the ocean surface water or the sea surface water which are present there along the coastal region. Which coastal region? The west coast of the continent. So in the zone of the trade winds, if we talk about the eastern coast of the continent, piling up of warm surface water is seen there. When we talk about the west coast of the continent, there is dragging away the warm ocean water from the coast, and so that when you can say a portion of water is dragging away from the coast, the region become vacant, and so that cold water from below the surface upwell there. The surface water is dragged away, and so that from this surface, the subsurface, the cold subsurface, comparatively cold you can say, comparatively cold subsurface water upwell there. And so that along the west coast of the continent, the temperature at the surface of the ocean water or sea water is felt a little cooler. It is felt a little cooler. Got it? So here we have the warm ocean water due to piling up of water. Here we have the cold ocean surface water due to the dragging away the warm surface water and upwelling of the cold subsurface water. Upwelling of the cold subsurface water. So in the zone of, I am writing here, in the zone of trade winds, two cases we will see here. The first case is along the east coast, of the continents. along the east coast of the continents. What is the first thing you have to consider? What is the first thing you have to consider? Here you have to consider that the trade winds are onshore. Trade winds are onshore here. And the second thing, due to this, they pile up. Warm surface water along the coast. Now what is important here to remember? It is important to remember here that we are talking about the east coast of the continent in the zone of trade winds. East coast of the continents, I am repeating here. Now what about the west coast of the continent in the zone of trade winds? The second thing I am considering here, along the west coast of the continents. Along the west coast of the continents, right? So the two things are again considered here. The first thing, trade winds are offshore here. Trade winds are offshore here. You can see trade winds are offshore here. And the second thing is that due to this, they drag away the warm surface water and consequently upwelling of cold subsurface water takes place. Cold subsurface water takes place. Got it? Okay. So wherever the upwelling of cold subsurface water takes place, at the surface the temperature is lower. Wherever there is piling of warm water takes place, the temperature at the surface is found warmer, or the temperature is found a little more. This is the case of trade winds. This is in the zone of trade winds we can consider. Now come here, in the case of, you can say, now we'll consider here that in the region of westerlies, if we consider, it is the zone of westerlies. So the same phenomenon become opposite. In the case of westerlies, the same phenomenon become opposite. And you can write the same thing, just changing two things there, right? What is that? See here. If I consider again some parts of continents in the way of these westerlies. Now in the zone of westerlies, if I would like to write here in the zone of westerlies, so what thing we have to consider? What is the condition for these westerlies? In the zone of westerlies, the westerly winds are onshore for the west coast of the continent and offshore for the east coast of the continents. Onshore for the west coast of the continent and offshore for the east coast of the continent. and it is seen in both the hemispheres. Not only in the northern hemisphere, you can see the same thing in the southern hemisphere too. So if it is so, you can write that in the zone of westerlies, since the winds are onshore for the west coast of the continent, they are able to pile up warm surface water along the west coast, and so that the temperature of the surface water along the west coast is a little more. We are talking about the zone of westerlies, right? So you can change the sentences here. You can change the sentences here, whatever we have written here for the trade winds. For the westerlies, you can change these things in just the opposite manner. For the west coast, the winds are onshore. For the east coast, the winds are offshore. Wherever the winds are onshore, they are able to pile up warm surface water. Wherever the winds are offshore, they are able to drag away the warm surface water, and so that upwelling of cold subsurface water takes place there. This is the fact, this is the thing, this is the process. And in this way, particularly for the trade winds and for the westerlies, you can consider these two things. What about the polar region, or in the zone of polar winds, you can say? So in the zone of polar winds, it is seen that the temperature at the surface water is not getting changed along the coast as well as away from the coast. Why it is so? Everywhere the temperature of the ocean water is similar. It is the cold region. Throughout the year it is colder there. Throughout the year it is colder there. And so that if winds are piling up cold water along the you can say coast region where they are onshore, so there is not much change can be observed, particularly in the case of temperature. You can say not much change in the temperature is found there along the coasts of continents, right? So in the zone of polar winds, and one thing which is also important there, that in the zone of polar winds, the land is not expanded horizontally or latitudinally very clearly or very demarcated, as we can see in the zone of trade winds and westerlies. We have so many of islands in the zone of polar winds, and so that the demarcations are not well there in the zone of polar winds, right? So whenever you have to discuss about the impact of polar winds, you have to consider only the trade winds and the westerlies. You can give the example of trade winds and westerlies. And what is important here, that in which zone these trade winds and westerlies are, along for which coast, you can say, for which coast these trade winds and westerlies are onshore, for which coasts these trade winds and westerlies are offshore. Wherever they are offshore, they drag away so much of surface water, and so that upwelling of surface water is taking place there. Wherever they are onshore, they are piling up so much of surface water along the coast, and so that they are able to increase the temperature along that coast, right? So with this diagram you can understand the things. The direction of arrows tells you that for which region the winds are onshore, for which region the winds are offshore. In that way you can consider the things. Got it? Okay. So here now we will come on our text, right? The winds blowing from the land towards the ocean drive warm surface water away from the coast, resulting in the upwelling of cold water from below. Here we are talking about the offshore winds, right? It results into the longitudinal variation in the temperature. Contrary to this, onshore winds pile up warm water near the coast and it raises the temperature, right? In a very precise way, you can write the thing in this manner. And if you are getting confused regarding this term longitudinal, it is written here somewhere, longitudinal variation. Longitudinal variation means that the variation in the temperature is observed from west to east or east to west, you can say. If we are considering the east coast of continent in the zone of trade winds, see here, see the diagram. If we are considering here this east coast of the continent in the zone of trade winds, so the variation in temperature is seen longitudinally. Longitudinally means from this east coast, or for the ocean it is the western margin of the ocean, from the western margin of the ocean towards the eastern, towards the east, the temperature is decreasing. Why? There is piling up of warm water here along the east coast of the continent or along the western margin of the ocean water. Always consider, always keep in your mind the direction. It is very important, because on the basis of direction you will be given the statements in the question and you get confused. When I say that these are the two continents and there is an ocean between these two continental parts, say it is Atlantic Ocean, on the western side we have North America, on the eastern side we have Europe, and it is the zone of Atlantic Ocean. So it is the west coast of the European continent, it is the east coast of the North American continent, right? The Atlantic Ocean is surrounded by the east coast of North America, west coast of Europe. The same thing can be said like this, that the western margin of Atlantic Ocean touches the east coast of North America, the eastern margin of Atlantic Ocean touches the west coast of Europe. So to the western margin of any ocean, you can say the eastern coast of continent is touching, and the eastern margin of the ocean is touched by the west coast of the continent. Got it? So in that way you have to consider the direction always. Always consider the direction in that way. The same thing can be given you, piling up of warm water along the western margin of the ocean. It can be written like this. Wherever I have used the east coast of the continent or the west coast of the continent, you can be given the same statement in the manner where they are not using the term east coast and west coast. They can use the term western margin of the ocean or eastern margin of the ocean. Right? So you have to read very carefully that what kind of thing, what kind of a statement is given there, and what is the particular word is used in the statements. East coast, west coast, eastern margin, western margin. So I hope that if you consider and if you remember this diagram, if you understand this diagram particularly, obviously you are able to infer all those statements. All those statements you will be able to infer. Got it? Okay. Now come to here the next factor. The next factor is talking about the ocean currents. See, we have a separate chapter of ocean currents in the later sessions. I will discuss. In one of the later session, I will discuss about the ocean currents particularly. But here you have to consider what are ocean currents. So when we say that rivers are flowing in a certain direction on the land surface, They are flowing in the form of a channel. They are particularly following the slope gradient of the mountains or hills. On almost flat land, they are also following a particular direction. So in the same way, if you say that the surface water of the ocean is flowing in a certain direction, like the rivers on the land, those are called as ocean currents. And these ocean currents are observed in various parts of the ocean. Particularly, major ocean currents are found along the coastal region. Along the coast of the continents, these currents are flowing either south to north in the direction from south to north or north to south in both the hemispheres. But apart from discussing about the direction of the ocean currents, one thing you must consider here, that whenever this ocean surface water is moving in a particular direction in the form of a channel, in the form of a, you can say, in the form of a river on the land, right? So these ocean currents are also divided into two types. These are divided into two types on the basis of their temperature condition. The ocean currents are considered as warm ocean current and cold ocean current. When I say warm ocean current, that means it is a current which basically increases the temperature of the ocean water at its destination. And when we say that an ocean water is decreasing the temperature of the ocean water at its destination, it is called cold current. We will discuss these cold currents in the later session in the chapter of ocean currents, but here you have to consider only that ocean currents are considered as warm currents and cold currents. Warm currents are defined as those currents which are able to increase the temperature at its destination or in the region through which they are passing, and the cold currents are those which are able to decrease the temperature of the ocean surface water at its destination or in the region through which they are passing. Right? In that way you have to consider. So obviously, if you are saying that in a region or along the coast a warm current is moving, obviously you can find more temperature of the surface water there. Wherever the cold currents are flowing along the coast, you can say that there is less temperature or cool temperature of ocean surface water. So in that way you can say ocean currents are affecting. Warm ocean currents raise the temperature in the cold areas, while the cold currents decreases the temperature in the warm ocean areas. Obviously, if we are saying that the temperature is got raised in a region, that means the region was cold earlier. That region was cold earlier, and due to the after the reaching of a warm current, the temperature is got raised. If a region was warmer earlier and a cold current has reached there, so it is able to decrease the temperature of ocean water in that area. Got it? Okay. So in that way, ocean currents are also able to affect the temperature, and so that it is considered as one of the factors here. Okay. So these are the ocean currents. Okay. Here I have taken an example, and this example you will see here, see in the chapter of ocean currents also. I have taken one of the examples here, Gulf Stream, which is a warm current, and this Gulf Stream is a warm ocean current that is flowing along the east coast of North America from south to north, from the equatorial region towards the polar region. Right? In that way you can consider. So Gulf Stream, which is a warm current, raises the temperature near the east coast of North America and the west coast of Europe. Why west coast of Europe? Because this Gulf Stream flowing in a particular direction along the east coast of North America, after reaching a certain latitude in the temperate zone, in the influence of westerlies, it get diverted towards the European continent, and then it reaches along the coast of the European continent after crossing the whole of the Atlantic Ocean longitudinally. Longitudinally, it crosses the whole of the Atlantic Ocean, and then it reaches to the west coast of Europe, where, since it is a warm current, it is able to raise the temperature along the west coast of Europe. That is what it is written here. Right? In the same way, it is written that the Labrador current is a cold current. Labrador current is a cold current. In the map you can find, in your atlas, in the latter pages, there is a page for ocean current. There you can find that some of the ocean currents have been shown with the red arrow. Some of the ocean currents have been shown with blue arrow. The ocean currents which have been shown with the blue arrow are cold current. And in the region of Atlantic Ocean, between the Greenland and Newfoundland, you can find a blue arrow that is coming from north to south, and it has been shown as Labrador current. Since it has been shown as blue arrow, it is a cold current. It is representing a cold current. So cold Labrador current is coming from the northern part. It lowers the temperature near the northeast coast of North America, because this Labrador current is coming from the northern side. It reaches up to an island situated or located at the northeastern region of North America. And when this cold current reaches there in the region of Newfoundland or in the region of Northeast American coast, so there it decreases the temperature in that region. Got it? So it is the condition. All these factors influence the temperature of the ocean currents locally. It is talking about locally. Why it is so? Because wherever these factors are working, only the changes in temperature can be observed there. If we are talking about that prevailing winds reach along the east coast of a continent, or they are moving away from the west coast of the continent, so locally along the east coast and the west coast, they are changing the temperature conditions accordingly. Wherever the warm ocean currents and cold ocean currents are reaching, they are changing the temperature condition of the ocean water accordingly. Got it? So in that way it is written here. Okay. Now come to one more thing which is also important here. Very important statement is this, and consider it very carefully. Very carefully you have to consider it. What is written here? The enclosed sea in the low latitudes record relatively higher temperature than the open seas, whereas the enclosed seas in the high latitudes have lower temperature than the open seas. Very important thing, very important statement. And obviously you can take it as a factor. We have discussed about 4 factors, so you can consider this condition as a 5th factor. And the heading you can give there is the closeness and openness of the sea. Closeness and openness of the sea. You can take this heading there. What is written here, that when we are talking about the low latitudinal region are those for which the solar radiations or the insolations are near vertical, almost vertical you can say, and so that throughout the year they are the heated region. The high latitudinal regions are having slant or oblique insolations, slant or oblique rays of solar radiation, and so that throughout the year the regions are colder. Right? It is the basic thing. Okay. Now, if you remember and recall the chapter of heat budget and chapter of heating of surface there we have said that the region for which the insolation or the solar radiation is vertical almost, those regions are heated up more. Those regions are heated up more. And so that the regions show more and more temperature. If I say that there is a region for which the solar radiations are oblique, for which the solar radiations are slant, that means those regions are having less temperature. Those regions are having less temperature. If it is so, what is important here? The important thing is that the heating condition is seen again different for land and water. For the land and water, the mode of heating is different. Differential heating of land and water. The land gets heated up rapidly, cools down rapidly. The water gets heated up slowly, cools down slowly. All we know. Now apply this condition on a sea which is enclosed in a latitudinal zone, and in the same latitudinal zone there is a sea which is open. So consider here, we have a sea called Mediterranean Sea, and also to the you can say to the west of this Mediterranean Sea we have portion of Atlantic Ocean. We have portion of Atlantic Ocean. And also towards the eastern side we have Black Sea, we have Caspian Sea. All these seas are there to the east of Mediterranean Sea. Now if you consider these sea, and not only this, in the low latitudinal region you can also consider there the Persian Gulf, you can consider the Red Sea. See all these seas and Gulf areas there in your atlas. So whenever you can say a sea or a Gulf area is enclosed or is surrounded by the land area completely or partially, so there is more effect on such enclosed, completely enclosed or partially enclosed water areas from the surrounding land area. More effect can be seen. If we see that this sea is enclosed here, this sea is enclosed here, so the surrounding land part, if this surrounding land part is located in the low latitudinal region, this surrounding land part is getting heated up more and more. This surrounding land part is getting heated up rapidly, and so that the heat, the more amount of heat which is absorbed here or which is taken here by this piece of land, it is transported or it is transmitted to the enclosed water area, right? So that in the low latitudinal region it is very obvious that the land is getting heated up very rapidly and the land is getting more heat than the water area. But if the water area is enclosed, so obviously there is transmission of heat, there is transfer of heat from the surrounding land area to the enclosed water area, and so that the average temperature of that enclosed water area, that enclosed ocean water, that enclosed sea water, not ocean water, sea water, is found a little more than what? Than the open sea. Which is the open sea? Which is not completely surrounded by, the land area from all sides, or you can say in the maximum area or along the maximum of its periphery. Got it? If you see a sea to the west of United Kingdom, that is North Sea. So North Sea is not considered as a as an enclosed sea. It is an open sea. It is an open sea. But if you consider Mediterranean Sea or Aral Sea, or you can say Black Sea or Caspian Sea, right? Red Sea is not completely enclosed. It is partially enclosed. You can talk about the Persian Gulf. It is partially enclosed because a little portion is open in the north and south of these two, Red Sea and Persian Gulf. Mediterranean Sea is again a partially enclosed sea because it is a little open towards the western side between Spain and you can say the African region. And you can also see a little portion of this Mediterranean Sea is open nearby the Red Sea, right, in the eastern side. Got it? So what is important here to discuss, that in the low latitudinal region, if the sea is enclosed, so it is taking a little more amount of heat from the surrounded land. From the surrounding land, it is taking more heat, and so that the temperature of that enclosed sea is a little more than the open sea in the same latitudinal region. In the same latitudinal region. Right? Okay. If there is open sea here, the temperature in the open sea in the same latitudinal region is a little lesser. In the open sea I am talking about, hai na? In the open sea it is a little lesser than the enclosed sea which is found here. Because in the enclosed sea the temperature is coming from the surrounding land. Now this thing is opposite for that enclosed sea which is found in the high latitudinal region, because in the high latitudinal region, for the high latitudinal region, the solar radiations are slant, the solar radiations are oblique, and so that not much insolation is received by the land surface, and so that the land surface is colder. Land surface is rather colder. If it is rather colder, so obviously the enclosed sea between that cold land area is also, it is becoming cold. It is also becoming cold. In the same way, you can say that if it is becoming cold, in the same latitudinal region, if you see the open sea, if you see an open sea which is not completely affected by the cold conditions of the land, which is not completely in the touch of the cold land area, so that you can say that the temperature in the open sea is a little more. You can say the difference in temperature can be observed only in points, but it is a fact that in the open sea the temperature is found a little more than the enclosed sea in the high latitudinal area. That is what written in this statement I was talking about, right? So you can take this as one of the factors which also affects the temperature, because since it is only talking about the enclosed seas and open seas, so that again you can say that it is considered as a factor which affects the temperature of the ocean water and sea water locally. Okay. So in this session, I have discussed with you about these factors. I am ending this session here because I hope that you need a little gap here. You need a little free time here. Okay. So just after this session, I will take the next session for you. That in that session we will discuss about the vertical and horizontal distribution of temperature, how temperature is getting distributed horizontally, how it is getting distributed vertically. We will see the trend. That is the last portion of this chapter of temperature of ocean water, right? So see you in the next session. Thank you.